Well, I'd like to thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And of course, today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including some of the very latest models incorporating new cutting-edge technology. Some pretty cool stuff. We're going to see that. So, over the years, I would typically begin these presentations with a discussion of the importance of STEM education and talk about changes in the manufacturing environment, and of course, the growing need for highly skilled workers in the modern workforce. But I think at this point, it's really been pretty well established just why technology-focused education is so necessary. And so, with that in mind, I'm going to dispense with that preamble and pretty much jump right into the discussion of what Fisher Technic is, and then I'm going to show you each of the current models that are available in the simulation family. Now, Fisher Technic simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line of models consists of a series of pre-assembled small-scale models, which are designed to replicate in both appearance and in function various automated robotic machines and systems that are commonly used in commercial manufacturing processes. Now, before we begin to look at each of the models, I'm going to provide you with just a little bit of background on what Fisher Technic is. Fisher Technic has been creating tools for teaching students of all ages how technology works for nearly 60 years now, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, in the Fisher Technic system, they were designed with more of an engineering mindset. The core building block, as you see in the picture, is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts used in the system are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will help technical builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen, noted for countless innovations used in the construction and the automotive industries. Now, at the time of his death in 2016, Mr. Fischer held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. To give you an idea, prior to creating Fisher Technic, Mr. Fisher is also credited as the inventor of synchronized flash photography. That was back in 1949. And he's also been established as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction. Up until recently, they also produced numerous components used in the automobile assembly process, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fisher Technic building sets, it's whether we're talking about those that are used or sold in the retail market, the toy end of things, or those designed for classroom use, the focus has always been on helping to foster an understanding of technology. Now, many of the products that you would see in the Fisher Technic lines are designed as subject-specific sets that focus on different STEM-related topics, areas such as mechanics, pneumatics, robotics, renewable energy, and things like this. Now, many of these sets will either include curriculum or they have detailed teaching and activity materials. And in most cases, students will basically be asked to build a progression of models using the unique Fisher Technic building system. And then they perform various experiments which allow them to explore and understand key aspects of the study or the subject being studied. Now, the line of Fisher Technic simulation solutions, which of course are what we're focusing on today, are something much different. Again, the line consists not of kits, but these are a series of pre-assembled, small-scale models which are designed to replicate, both in appearance and function, various automated robotic machines and systems. Now, some of the models found in the Fisher Technic simulation line will include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models, which are designed to focus on specific automated processes, fischertechnik also offers several variations of an integrated factory simulation model. Now, in these factory simulation models, they usually have four or more individual workstations, and commonly what you'll find are a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, and they're designed to all work together as one self-contained material cycle. And of course, we're going to look at these models and some of the variations of them a little bit later in the presentation. Now, before we do that, I'm going to very briefly outline some of the advantages of using fischertechnik solutions. The first one is fischertechnik simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. Next thing is that the models, once again, are designed to realistically replicate in both appearance and function common automated systems. And these are, again, things like conveyor belts, sorting machines, robotic arms, and so on. Now, because the models are compact, and in most cases, these are tabletop size models, they're not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings, let's say in a trade show environment. The next aspect is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of the models we're going to be looking at, or most of the models we're going to be looking at, are available in 24-volt versions designed specifically for industrial users, with select models also available 9-volt versions for those not versed in the use of PLCs. Now, in the case of the 24-volt versions, they're designed to be used with industry-standard PLCs. Now, it doesn't really matter whether you prefer to use Allen Bradley controllers, Siemens controllers, or if you use controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or of course, there are many others. In most cases, you can control the 24-volt versions of the fischertechnik models with the PLC that you prefer. And likewise, just as you can use your choice of controller, you can also use your choice of programming language, whatever it is that you're most comfortable with. Now, please note that in the case of most of the models that we're going to be talking about, at least in the early part of the presentation, there is no PLC included. And any of the programming or programming guidance, any of the wiring from the model to the PLC itself, those are all going to be the responsibility of the end user. Of course, this really should not be an issue as these models are again designed specifically for industrial users or for those who are already teaching or exploring industrial processes involving PLC programming. Now, as I touched on before, there are also 9-volt versions available, select models. And in the case of these 9-volt models, they will ship pre-wired to fischertechnik's own proprietary controller. And depending on the ones we're talking about the robotics TXT controller or the TXT 4.0 controller. And each of the controllers which ships with these 9-volt models is pre-programmed using fischertechnik's own RoboPro graphic programming software, or in some cases, C++. The only additional component that's required with the 9-volt models will be the addition of one or more power adapters as specified with each model. And of course, as this comes up, I will mention this during the presentation. Otherwise, in most cases, these 9-volt versions should be ready to use straight out of the box. Now, the next thing is if you're involved in demonstrating or exploring IoT, what's commonly known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, excuse me, fischertechnik now also offers a special IoT-focused version of the factory simulation I discussed earlier that's designed specifically for exploring and understanding cloud-based control and what is sometimes referred to as Factory 4.0. Now, in the case of these models, they're designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss and look at this a little bit in detail just a little bit later. Finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, You'll pretty quickly see that the entry point for many of these products can easily be $30,000 to $40,000 or even much more. Fischer-Technic simulation solutions, on the other hand, have an entry price at just a fraction of that, as well as being, again, compact, realistic, and high quality learning and demonstration tools. So, on that note, we're going to begin our look at each of the models which are currently available. And we're basically going to begin with a look at some of the more basic modules. And of course, we'll work our way up to the larger factory models, which I've touched upon, which again, what you'll see will consist of several individual workstations designed to showcase an entire production cycle. So the first one we're going to look at is the basic conveyor belt. And this is essentially a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. In the case of these conveyor belts, multiple conveyors can easily be connected to increase the length of transport if so desired. Components that you'll find on this model will include an excess motor, a push-button limit switch, two photo transistors, and two LED light barriers. The dimensions are approximately 14 by 10 by 4 inches, and it has a weight of under 2 pounds. The model is available in both 24 volt with a multi-pin connector, and this will be 26 pins with a 2.54 millimeter grid as seen here. Again, the 24 volt version of this model, as well as many of the 24 volt versions we're going to be looking at in the early part of this presentation, will require you to provide the PLC and the programming. There is also a 9-volt version, which is connected to a pre-programmed robotics TXT controller as shown here. In this case, you'll need one power adapter required for operation. And I will mention that for this and for all the models we're going to look at today, if you want to see more detailed specs on any of them or download different sheets that may be available, you can look at the product listings on the Studica and the fischertechnik.biz websites. And you can also find a product brochure, which we're happy to mail you. I'll provide you information on how you can get that from us as well at the end of the presentation. Moving right along, the next model we're going to look at is the punching machine with conveyor belt. And this is essentially a variation of the conveyor belt that we just looked at, except of course it's got a machining station built onto it. In this case, the components on the model will include two excess motors, two push-button limit switches, two photo transistors, and two LED light barriers. The dimensions are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. It's again available in the 24 volt variation with a 26 pin connector and a 2.54 millimeter grid as shown here. And the 9-volt version comes pre-wired to the robotics TXT controller, which requires one power adapter. The next model is the indexed line with two machining stations. And this model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Other components on this model will include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches. It has a weight of about 8 pounds. It is currently available in a 24-volt version with a 26-pin connector and a 2.54 millimeter grid as shown here for use with PLC, and also a 9-volt version wired to the pre-programmed robotics TXT controller and requiring 2 power adapters for this one. I will mention, though, that this model is being phased out in both the 9-volt and the 24-volt versions later this year. So if you're going to need something like this, this is going to be a while supplies last. The next model we're looking at is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 can turn 180 degrees. Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components you'll find in this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. The dimensions of the model, are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And again, this is available in both a 24-volt version with the 26-pin connector and a 2.54 millimeter grid, designed for use with the PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one power adapter. Next model we're looking at is a vacuum gripper robot. And starting with this one, we get to show you the models in motion. So as you're going to see here, the vacuum gripper is essentially, again, a variation on the three-axis robotic model with a vacuum, but this time with a vacuum gripping device built onto it. And the model, again, is designed to precisely pick up and position workpieces in three-dimensional space. This model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions for the model are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt version of this model, as well as all the 24-volt models we're going to be looking at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector, and in this case, it's a 34-pin with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the 24-volt version of this model is with all of the 24-volt versions that we've talked about so far require you to provide the PLC and the programming. There is not a 9-volt version of this one, so this is a 24-volt version only. We'll just let this play through. And I think, okay. Moving right along, the next model we're looking at is the automated high bay warehouse. In the case of the high bay warehouse, the model features a transfer station with a conveyor belt along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays along with 9 individual storage spots. Components found in this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and along with a selection of different colored workpieces, each with a carrier tray. Now, the one thing I'll mention is this model is a favorite of educators who are involved in teaching programming. And the reason for that is because it gives students a lot of very specific coding tasks to address. So if that's something you may be concerned about, this is a good model for that because you have to deal with the precise movement of the picker arm, being able to precisely store and retrieve all the work pieces on the shelves and so on. Getting back to the dimensions on this model are approximately 19 by 28.5 by 15 inches. It has a weight of 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal in both the multi-pin connector, 34 pins again, with a grid of 2.54 millimeter grid, as well as additional PCB terminals with pushing connections for all inputs and outputs. You supply the PLC and the programming. There is a 9-volt version, comes pre-wired to the pre-programmed robotics TXT controller, and again, you need a power supply for that, which we'll talk about as well. Next up is the multi-processing station with an oven. And what you're going to see with this model is basically a furnace simulation with a pneumatic sliding door. In the case of this model, there's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components found in the model will include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions are approximately 20 by 14 by 12 inches, and it has a weight of 11 pounds. Again, it's available in both the 24-volt version for use with the PLC of your choice. Again, it's a relay board for motor polarity reversal and a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the 9-volt version in this case is connected to two robotics TXT controllers, and as such, it will require two power adapters for use. We'll just let this play through for another minute. And there we go, delivered. The next model in the progression is the sorting line with color detection. And what you'll see here is a simulation that features a system for detecting work pieces of different colors that sorts them via conveyor belt into three different storage areas. Components found in the model, again, two mini motors, five phototransistors, five LED light barriers, three solenoid valves, a compressor, and an optical color sensor. The dimensions are approximately 20 by 14 by 12 inches with a weight of about 10 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both the multi-pin connector, again, 34 pins with a 2.54 millimeter grid, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, the end user has to provide the PLC and the programming with this one. 9-volt version, again, comes pre-wired to a pre-programmed robotics TXT controller. And in this case, you would only need one power adapter for that. And we'll let the sorting finish here. Very nice. The next model we're looking at is the first of the factory simulation models. And this basically, again, combines the last four models we reviewed. So you're going to have a vacuum gripper robot, an automated high bay warehouse, a multi-processing station with the oven, and the sorting line with color detection that we just saw. You're going to see these four models combined into one self-contained material cycle. And what you're going to see in the model or in this video is a cycle that works like this. Work pieces get retrieved from the automated high bay warehouse where they've been stored, and they're retrieved by the vacuum gripper robot, which moves them along to the multi-processing station with the oven. The piece gets worked on, and after the work piece has been processed by that station, it's then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've discussed the components on each of these models previously, I'm not going to belabor that. But what I do want to mention are the dimensions of this model as a whole. Again, because it combines four individual models into one work cycle, it has a much larger total footprint. In this case, we're talking about 39 by 31 by 16 inches, and you have a weight of between 43 and 46 pounds, about, depending upon whether we're talking about the 24 or the 9-volt variation of this. Now, due to these dimensions, please note that this model and any of the factory models we're going to be looking at today, there are going to be several, any of the factory models can only be shipped flat as freight on a pallet. So these are not UPS shipping models. These are truck shipped as freight on a pallet. I also want to mention that with some of the factory models that we're going to be looking at a little bit later, they can be kind of high demand. So just allow for a lot of times 2 to 3 weeks for processing just to be able to get these in and out. Uh, Again, it's available in both 24-volt and 9-volt version. In the case of the 9-volt version, it's wired to five robotics TXT controllers. And because of the way they're daisy chained, you'd need to get, I believe, three power adapters for that one. Of course, the 24-volt version requires you to provide the programming and the hardware. Now, before we move on to the next group of models, I did want to mention that there is also a storage option available, not only for the factory models we just looked at now, but also for the ones we're going to see a little bit later in the presentation. And we really suggest this, whether you're going to be transporting the model, or even if you just want to protect it when it's not in use, this is really a good idea. Basically, what you have with the travel case is the travel case consists of an aluminum case maker profile with plastic plates, and it has steel ball corners, along with four steel tilt handles and angle protection corners. Now, the upper section of this case is partially lined with soft foam blocks in different heights that'll help to cushion the factory model. And it also has three internal zipper pockets, as you see there, that are used for storing the cables, the work pieces, and any other accessories that might be used. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model itself can remain in this bottom section of the case and it's fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds. So this means if you have the model in the case, you're going to be coming pretty close to 100 pounds total with it. Please note that even when you're using the travel case again, these models will always need to be shipped flat on a pallet to just protect them from any possible damage in transport. The next group of models we're going to look at focus on the area of IoT. Now, these are what we call the Training Factory Industry 4.0 models. Now, this group of models is designed to help address how the recent changes in industrial production driven by digitization have created a real need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the factory simulation model we looked at before, such digitization activities can be simulated, learned, and applied on a small scale before, of course, they're implemented on a larger scale. Now, in the case of this video, because we have a very nice narration that'll give you an overview of how the whole factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. And here you go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first in, first out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, so just to summarize a couple of the big points quickly, here are some of the topics that can be addressed with the fischertechnik Training Factory Industry 4.0. Again, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production, lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, the connection of upstream and downstream logistics processes, and of course, the creation of your own programming using C++ if you chose to. Now, as you just saw, the model incorporates many features not found in the models we've previously discussed, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each workpiece enables the position of each of the pieces in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers communicate with one another. Now, in regards to the 24 volts specifically, I should mention that it's a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik's robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik-based cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is of course a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there's also an IoT gateway using Raspberry Pi with Node-RED. And this allows you the option of not only presenting and using data on a dashboard in the fischertechnik cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard that you could create. The model also incorporates newly developed 24-volt adapter boards to an interface to the PLC. And these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for phototransistors and buttons. Now, unlike the previously discussed 24-volt models that we've looked at, the new 24-volt training factory Industry 4.0 model includes access to a sample program. In this case, the program is created in structured text format and it was designed around a Siemens S7 to 1500 PLC. And this program is available for download on GitHub. So when you purchase this, you receive access to the sample program on GitHub, again in structured text. Of course, the training factory can be controlled by other PLC models and brands once the end user makes adjustments to the sample program. And for this, the source codes also needed are also available for free download from GitHub. Now, all of this information and much more is also included in a 152-page PDF manual that can be downloaded from the fischertechnik website and which is also available from us upon request. And of course, I'll give you information on how to connect with me at the end of the presentation. So if you did want to receive a copy of this or any of the other manuals I may mention in the last part of this, you can just email me and let me know what you're looking for. I'll be happy to send it off to you. I will also mention that there are now also two additional variations of the 24-volt model available, and we're going to discuss those when we get into the pricing of the models a little bit later. Now, in the case of the 9-volt model version of the model, the control is facilitated through the use of 6 robotics TXT controllers. And again, with these, with the 9-volt version, all of the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation which accompanies this model, once you do that, you should pretty much be able to get started. The 9-volt version will require the addition of 3 power adapters. And while it should go without stating, whether we're talking about the 9-volt or the 24-volt versions, because these are IoT focused, this also requires that the end user, of course, has the ability to access the internet, as well as a tablet or some sort of device for accessing the cloud-based dashboards we've been talking about. Just to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches on the base, and they have a weight of approximately 51 to 53 pounds, depending on which version we're talking about. And again, as with the 2 factory simulation models we looked at before, we do recommend the optional travel and storage case to help protect the model during travel or storage. And that's essentially the Training Factory Industry 4.0 model, which is again available in a 9-volt and a 24-volt version. But we do have some other models to discuss that came along as well. The first model we're going to be looking at here is this one, the new quality control with AI. And basically what you're going to have here is this is ideal for visualizing AI in a hands-on manner, and it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. Excuse me. So this is basically a fischertechnik sorting line that comes with workpieces in 3 different colors. You'll see what makes it a little bit different than the storage lines or the sorting lines we've looked at before. In this case, the workpieces are each marked with 3 different processing characteristics, as well as various fault patterns. So what happens with this model is the workpieces are put on the conveyor belt, they get scanned by the camera. and they get classified with the use of trained AI. Now, depending upon the color of the piece, the feature, the characteristic that's printed on the piece, or any fault pattern that might be printed on there, the work pieces are then sorted by the artificial intelligence based on the quality or the features. Now, the AI used here is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik's TXT 4.0 controller, and the model sequence control is implemented in the RoboPro coding program environment and also in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample project is provided for explanation. Oh, getting ahead there. We'll also mention that this is again ideal for training, simulation, and demonstrating, and it's the visualization of AI systems, machine learning, and neuronal networks. It's available only in a 9-volt version at this time. And because it uses one robotics TXT controller, it will require one power adapter. Okay, as I jumped ahead before, the next model we're going to look at is a newly released, it just came out at the end of last year, and it's the Agile Production Simulation or APS model. And it's the very latest version of the factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also incorporating AI, and this time with a digital learning platform also included. Now, the factory of the future is the subject of numerous research projects in science and in industry. Forward-thinking companies rely on automation, modularity, artificial intelligence, and agility to remain competitive. Now, in order to promote these topics in industry and in research, students, apprentices, as well as employees all require the corresponding know-how and awareness to know how to deal with these complex areas. And this is where the learning concept agile production simulation comes in. It simulates processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and it also replicates automated processes on a small scale. This will include from goods receipt to modular production to quality assurance. The learning materials that accompany this will also help to translate the hands-on simulated processes into future skills for both students and for teachers. And the digital twin of the model significantly intensifies the learning experience. Now, as we don't yet have a narrated video of this brand new model, I'm going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And this is, of course, where the material flow of a workpiece will begin and end. Now, in this case, the raw material is delivered at the goods receipt slot, positioned on the color sensor for quality control using the 6-axis robot with a vacuum gripper, and then it's encoded on the NFC reader. The robot, in this case, places the workpiece on the automated guided vehicle, or AGV as we may refer to it during the presentation, and the AGV will transport it to where it needs to go. The module also contains the central control unit, which is a Raspberry Pi, and the environmental sensor, which measures the different environmental conditions on the factory. There's also an integrated movable camera, which can be swiveled in 2 axes and provide an insight into the entire factory via the fischertechnik cloud-based dashboard, much like we saw in the previous example of the training factory. Now, at the end of a cycle, a finished workpiece, just as it starts here, is also delivered back here by the AGV. Now, next up, the next place that a workpiece could go after the goods receipt is usually the high bay warehouse, although again, because this is an agile production simulation, you could switch up the order of processes if so chose. But in any case, let's assume it goes to the high bay warehouse. The high bay warehouse contains 9 slots again for workpieces. It has its own stacker crane and a vacuum gripper that picks up the workpiece from the AGV, the automated guided vehicle, picks it up from there, at the docking station and hands it over to the stacker crane for storage. The workpiece is then placed into a workpiece carrier for storage, and retrieval of the workpieces is done by a first in, first out principle. Next station it can go to is the drilling station, and this consists of a docking station, again, for the AGV to come up there, a vacuum gripper that places the workpiece onto a conveyor belt from the AGV from where it is transported under a drilling head. So you basically have a simulated drilling process that takes place, and after that, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places it back into the AGV. Next up, we're going to look at the milling station. And the milling station consists of a docking station, again, for the AGV to come up to, and a vacuum gripper that places the workpiece onto a conveyor belt, once again, where it is transported under the milling machine. There, the milling of two pockets is simulated. And after this process, the workpiece is again placed back onto the conveyor belt at this station and transported back to the gripper with this station. And again, that gripper moves it back onto the automated guided vehicle. Next up is a quality assurance module, which is somewhat similar to the one that we saw previously as a standalone unit. In this case, a vacuum gripper places the workpiece on a conveyor belt. It's transported underneath the camera and scanned there. In here, the workpieces will come in three different colors, again, red, white, and blue, with three matching features, drilling, milling, or drilling and milling, as well as various fault patterns. And again, this is all classified using the trained AI. Now, depending upon the color, the feature, or the fault pattern, the workpieces are then either placed back onto the AGV as being acceptable goods, or they're sent to a reject container as not okay or defective. Now, just looking at the AGV, of course, is what transports the workpieces from one module to another at this factory. It's essentially a track-bound vehicle that follows the printed black track, such as you see in this picture, and it uses ultrasonic sensors to detect obstacles that may be in its way. The vehicle has omni wheels, which allows it to move in all directions. Two buttons and a photo transistor help the vehicle dock to individual factory modules, and the AGV receives its driving commands from the central control unit, which is an industry standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. Speaking of the battery pack, when the battery of the AGV runs low, it navigates towards the charging dock, where it is automatically charged with a charger with charge monitoring. The contacts on the bottom of the charging station connect with the AGV and the charging electronics. Moving right along, we'll just quickly review some of the technical specifications. You have a 24-volt power supply, 11 amps. The central control is a Raspberry Pi 4B. Individual modules are controlled with the help of 5 SPS Siemens S7 1200 PLCs. So right away, there are 5 SPS or Siemens S7 1200 PLCs that are included with this model. Additionally, the model also includes 3 fischertechnik TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to facilitate cloud access to the WEWA module for quality assurance with AI, as well as for the automated guided vehicle. There is a WLAN router for the WLAN network. Software used on the APS model includes SPS programs and structured text for the PLCs, TypeScript for central control on the Raspberry Pi. You have Node-RED for communication between the SPS and the fischertechnik TXT 4.0 controller. You have Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning and quality assurance with AI. Now, again, there's also a digital learning platform that comes with this, and it has a digital twin of the APS model, so that learning can be done with both the actual model as well as the virtual model. And now, as there's a lot more detail to cover with this specific model, with the APS model, if you would like to learn more, I strongly encourage you to sign up for our next webinar, which focuses specifically on the Agile Production Simulation model and discusses why the model is useful. But this will just give you a quick overview. But again, if you want a little more detail, a little more meat, a little more time spent with the model, and we do have some video that's been added to that, you should sign up for that webinar. If you look on our website where you access this, you'll see the sign up link for that. So at this point, you might be wondering, well, how much do these models cost? So we're going to take a quick review of each option along with the pricing. First up is the conveyor belt. In the 24-volt version, again, you have to provide your own PLC and programming. You're looking at a cost of $359.95. In the 9-volt variation that comes with the TXT controller, you're looking at $518.95. The punching machine with the conveyor belt in the 24-volt version is $464.95. And in the 9-volt version, $599.95. The index line with two machining stations, again, these are limited models at this point. The 24-volt version is $1,199.95, and the 9-volt version with the two TXT controllers is $1,394.95. Again, I do not expect these models to last past this year, so if it's of interest to you, you'd want to jump on these sooner. The 3D or three-axis robot 24-volt version, $1,094.95. Again, you have to provide the PLC and the programming. The 9-volt version with the TXT controller is $1,369.95. Vacuum gripper robot, only available in 24-volt version. You, of course, have to provide the PLC and the programming, $1,199.95. The automated high bay warehouse is available in a 24-volt version, $1,448.95. And for some reason, the 9-volt version is cheaper in this case, but it still has the TXT controller, and that's $1,318.95. The multi-processing station with an oven, the 24-volt version, is $1,287.95. Again, you provide the PLC and the programming. The 9-volt version is $1,474.95. That comes with the TXTs. Sorting line with color detection, the 24-volt version, $1,126.95, and the 9-volt version, $1,128.95. The factory simulation, okay, per my notes, only available in the 24-volt version at this moment. This is the regular factory simulation, not the IoT version. The cost for this is $5,299.95, only again in the 24-volt version. You provide the programming and the PLC. Training Factory Industry 4.0, the standard 24-volt version. Again, you provide the PLC and the or you provide the PLC. We do have the sample program, of course. Cost for that is $9,659.95, or the 9-volt version with the robotics TXT controllers used on there. Also, same price, $9,659.95. But as I mentioned before, there are two new variations of the Training Factory 4.0 for 24-volt use. The first version comes with the PLC connector board and all of the cabling. As anybody who's worked with this knows, there can be a lot of time spent with doing all the wiring and what have you. So this will help you out with that a little bit. Make that a little bit easier, having a connection board and what have you. The cost for that is $12,879.95. Again, you still need to provide the PLC. But for that, there is a version that does include the Siemens S7 1500 PLC. So if you want essentially an all-in-one solution, this would be what you would be looking at here. The EDU version, only available to accredited institutions that would be purchasing, you're looking at a cost of $19,639.95. For commercial users, that it's slightly more. It is $20,124.95. And again, this will come with the Siemens S7 1500 PLC. It comes with the connection board. It comes with the wiring. It comes with the program. Again, that's pretty much the whole shebang there. So again, you have two options here, either with just the PLC connection board, $12,879.95, or the version with the PLC, the S7 1500, either $19,639.95 or $20,124.95 for commercial users. Other items I've touched upon, the power adapters that are used with the 9-volt models, those are only $12.99 each, so those are pretty reasonable. The travel and storage case, specifically for the factory simulation, the 24-volt version we looked before, the non-IoT, and the IoT versions of the Training Factory Industry 4.0 models. The cost for that is $1,524.95. The quality control with AI model, again, the 9-volt version only, the cost for that is $2,249.95. You have to get the power adapter with that. Not available in 24 volts, sorry to say. And the Agile Production Simulation. This is a 24 volt only. Again, this comes with 5 Siemens S7 1200 PLCs and 3 TXT 4.0 controllers, along with the digital twin. The cost for that is $28,174.95. And there is a case that is made especially for the Agile Production Simulation. As you see here, the storage case, it's a two-tier unit, unlike the one we had looked at before. And let me just see here. It is let's just see here. Okay. This case is, of course, much larger. It's a two-tiered variation of the case we previously looked at for the other factory model. And this is designed to house the various components and modular sections of the APS model, because the APS model comes in modular sections where it all fits together, as you see from the little tabs on there. And this is perfect for storing it when not in use or when in transport. Again, we do recommend with all of the factory models and really with the APS that you strongly consider the storage case, and again, that you always ship them flat on a pallet. Again, this case has aluminum case maker profile with plastic plates. Each of the two separate case sections has steel tilt handles and angle protection corners for additional stability. There are also straps and internal zipper pockets, again, for storing the cables, the cords, the workpieces, etc. The lower case of each section is again lined with hard foam, and the upper case sections do have foam to help cushion the various models when in storage. And so you're looking again at a cost of $4,024.95 for the case. But wait, there's more. There's more. Yes. New this year is a 6-axis robot. As you heard me mention with the APS model, there is a 6-axis robot that is included. It is a 9-volt version only. It is $1,599.95. Of course, you require the TXT controller, or excuse me, you require a power adapter for that. It has the TXT controller and it is pre-programmed. No 24-volt version available at this time. There is a new 24-volt model, a production line. This is $1,599.95. This does include a PLC programming course with it. So that's a new model. We're going to add some more details on this soon. There is also a bending machine, a 24-volt version. This is $799.95. Again, these are for use with PLC, so you have to provide the PLC and the programming, but it does have a PLC programming course that, again, you have access to with this one. There are two add-ons specifically for the APS model we just looked at. You can buy an additional AGV so that you could theoretically have two AGVs on the factory floor at one time doing different things. The cost for the additional unit here is $2,249.95. And there's also an add-on module. Hopefully we'll see more in the future, but this is the first of them. It's an annealing furnace that can be added on and incorporated into the APS workflow, and the cost for that is $3,859.95. You will see that with this and with this model that there is an added, the PLC comes with that again, so you're all set to go. So if you did have any questions, this would be the time to use the chat windows, the question and answer window, all of which can be found on the Zoom toolbar. So if you did have any questions, you could feel free to type them in. If not, if you would like to take the next step, if you would like to request a copy of our Higher Education Industry Guide for 2025, if you'd like to receive the current pricing, we'd be happy to send that to you. If you'd like to ask any questions directly, request a quote, speak with a dedicated educational representative, any of those things, you can contact us one of several ways and get the ball rolling. You can call us here, 888-561-7521. We are open from 9 to 5, Monday through Friday, except for holidays. You can email us at info@studica.com if you just request a quote, some information. If you have any questions for me, if you'd like me to send any of the documentation I touched upon, you could email me directly, lance.zurich, lance.zurek @studica.com. So on that note, thank you very much for taking the time to attend today's presentation. We thank you for coming, and we look forward to hearing from you soon. Have a great day.